Now we will basically discuss price elasticity of demand and total revenue. What is the relationship between price elasticity of demand and total revenue? Know that total revenue is of a seller, of course, is the price of the good times the quantity of a good sold. Price of the good times the quantity sold of the good. The same thing, we can say that the total expenditure of a consumer, which is equal the price of the good times the quantity, of the good bought or demanded. So now what we will see the relationship between total revenue and the price elasticity of demand. Exactly, we're going to have a relationship, between total revenue and price elasticity of demand. In other words, total revenue, whether increases or decreases or remains constant, depends on whether the price elasticity of demand is elastic, inelastic, or unitary. So now we will see exactly how total revenue, is affected based upon the type of elasticity we have, based upon the type of demand we have, whether the demand is elastic or inelastic or unitary elastic. Now, let's talk about elastic demand curve and total revenue. So we have, as we discussed, that a demand curve can be elastic or inelastic or unitary. Okay, we're gonna see the relationship between total revenue and these three cases of the demand curve. When demand is elastic, what is the effect on total revenue? As the price changes in the elastic, demand curve. So if demand is elastic, then as you know, a price, or if demand is elastic, then as you know, we have already discussed that, then the coefficient of price elasticity of demand is greater than 1. That means the percentage change in the quantity demanded is greater than the percentage change in the price. So let's say given a price rise of say 7%. If the price rises by 7%, then it's expected, if we're talking about demand, is elastic. And the percentage change in quantity demanded is greater than the percentage in the price. So if price rises by 7%, then the expectation is that the quantity demanded will fall by more than 7%, say by 10%, as I stated here. So because the quantity demanded falls by greater percentage than percentage rise in price, then total revenue, of course, will fall. The percentage decrease in quantity demanded is greater than the percentage rise in the price. So total revenue will decrease. So when price rises, when demand is elastic, then total revenue will fall, because the percentage fall in the quantity demanded is greater than the percentage rise in price. Therefore, total revenue will fall. And if price decreases when demand is elastic, then total revenue will increase. Why? Because the percentage increase in the quantity demanded is greater than the percentage fall in the price. Therefore, total revenue will increase. So, as you can see, total revenue will follow the quantity demanded when demand is elastic. So, if price increases when demand is elastic, total revenue of course, will fall. And if a price decreases when demand is elastic, then total revenue will increase. And so total revenue will follow the quantity demanded in the case of an elastic demand curve. Now, of course, we can, show the relationship between a change in price and total revenue when demand is elastic. As we stated, at the introduction of the chapter, that the shape of the demand curve, when it is elastic, is more or less flat, as you see this one here. This is a flat demand curve. And this flat demand curve will, for any price change, will give us a change in quantity demanded that is much greater than the change in the price. So as you can see over here, let's say we start at P1. We start at P1, as you can see, and then between A and B, the demand is elastic. So when at point A, the price is B1, and the quantity demand is Q1. So total revenue, as you see, total revenue is price times the quantity demanded. So here, as you can see, total revenue is just the rectangle formed by O, B1, A, and Q1. This rectangle is, as you can see, we'll call it TR1. TR1. Now, at point B, the price is B2. The price is P2, and the quantity demand is Q2. So total revenue is the price OP2 times the quantity demanded OQ2. So OP2 BQ2 is total revenue. This rectangle formed by O, B2, B, and Q2 is total revenue 2. The rectangle is total revenue because it's the price times the quantity. This is the price along the vertical axis, and this is the quantity along the horizontal axis. Wow, it's clear? Now, as you can see, TR2, which is formed by O, B2, B, Q2, is larger, as you see, than TR1, which is formed by O, B1, A, Q1. So when price decreases, because we start from P1, and then we lower the price to B2. So when the price decreases, okay, when demand is elastic, then of course total revenue increases, and we just saw that, we just have seen that here, where the rectangle TR2 is greater than TR1, the rectangle TR1. Okay, now let's look at inelastic demand curve and total revenue. Of course, when demand is inelastic, then the coefficient of price elasticity demand is less than 1. Of course, the percentage, we take the absolute value, is less than 1, which means the percentage change in the quantity demanded is less than the percentage change in price. Okay, so as you can see over here, let's say the quantity given a price rise of say 10%. Okay, that a price rise of 10% will cause the quantity demanded to fall by less than 10%. Say, I wrote here 6%, because the percentage change in quantity demand is less than the percentage change in price, because we have an inelastic demand curve. So, because the quantity demanded, falls by less than the percentage rise in price, then total revenue, of course, increases. So, to conclude here, that when demand is inelastic, total revenue increases when price increases. And total revenue decreases when a price decreases. In other words, total revenue will follow the price when demand is inelastic. We can see, of course, the relationship between a change in price and total revenue when demand is inelastic. You know that, as I have already stated that before when I explained the introduction of this chapter, that the shape of the inelastic demand is, as you can see, sharp or is steep rather than flat. Okay, so this is a steep demand curve. So this one represents an inelastic demand curve. So here, if we start from B0 at the price B0, remember between A and B, the demand is inelastic. At points A, the price is B0, and point demand is Q0. So as you can see, TR1, total revenue, here is represented by the rectangle formed by O, B0, A, Q0. Okay, now let's lower the price to B1. So at B, the price is B1, and the quantity demanded is Q1. So total revenue is represented by the rectangle formed by O, B1, B, Q1. And as you can see, we call this one TR2. As you see that when the price rises, when price decreases from P0 to P1, as you can see, TR2 is less than TR1. So when price decreases, when demand is inelastic, then total revenue decreases. Okay? Now we move to unit elastic demand and total revenue. Of course, demand is unitary or unit elastic if the coefficient of price elasticity demand is equal, 1, which implies, this will imply that the percentage change in quantity demanded is equal to the percentage change in the price. Okay, so here, as you can see, a rise or fall, of course, in the price will leave total revenue unchanged because the percentage change in quantity demanded is equal to the percentage change in price. So if price increases, of course, the quantity demanded falls by the same percentage as the percentage rise in price. And when if price, of course, falls, the quantity demanded increases by the same percentage fall in the price. Therefore, when demand is unitary, then a change in the price, whether increase or decrease, will leave total revenue unchanged. Okay, now we move to talk about other elasticities, other elasticity concepts. So we have already talked about some kinds of elasticities, some demand, different demand curves. We talked about elastic demand, inelastic demand, unitary demand, perfectly elastic demand, and perfectly inelastic demand. Now, our topic is about other type of elasticities. Namely, we're going to be talking about, of course, cross elasticity of demand, income elasticity of demand, and price elasticity of supply. So we're going to start first with cross elasticity of demand. Of course, we're going to denote a cross elasticity of demand by the letter EC. Okay, so cross elasticity of demand measures the responsiveness of course, the in quantity demanded of one good to changes in the price of another good. Let's say we have two goods, A and B. So the coefficient of price is the coefficient of the cross elasticity of demand is going to be equal the percentage change in the quantity demand of good A over the percent change in the price of good B, assuming that we have two goods, A and B. as you can see over here. So the cost elasticity of demand is used to determine whether the goods in question are substitutes or complements. So the value of the cost elasticity demand can be negative or positive. Okay, if EC, of course, is the coefficient of the cost elasticity demand. EC can be negative or positive. If EC is greater than zero, then the percentage change in the quantity demanded, which is in the numerator, and the percentage in the price, the percentage in the quantity demand of good A, and the percentage in the price of good B move in the same direction. And this is the characteristics of goods that are substitutes. Therefore, when EC is greater than zero, then the goods in questions are substitutes. Example of substitute goods such as chicken and beef. If, for instance, you are to buy a chicken and you found that the price of chicken went up, then what you do, you go and buy a substitute for chicken, which is a beef, suppose. Okay? Assuming that the price of beef is still the same. Now, of course, so when EC is greater than zero, then the goods in question are substitutes. And if EC is less than zero, EC, the cross elasticity of demand, is less than zero, then the goods in question are complements, which means that the percentage in quantity demand of good A in the numerator and the percentage in the price of good B in the denominator move in opposite direction. And this is the characteristics of goods that are complements. Example of complements, like sugar and tea. Sugar and tea, assuming that you don't drink tea without sugar. To drink tea, you have to have sugar in tea. Therefore, sugar and tea are complements. Okay? So, when the price of sugar increases, then the demand of tea will decrease. That's why the cost elasticity, of demand is going to be negative. Now, the income elasticity of demand, of course, is represented by the letter or by the letter EI. EI is used to denote the income elasticity of demand. Okay, EI is the coefficient of the income elasticity of demand. The income elasticity of demand, of course, measures the responsiveness of the quantity demanded to changes in the income. Cool. Now, as you can see, EI is the percentage change in the quantity demanded over the percentage change in income. Of course, EI, or the income elasticity of demand, is used to determine whether the good in question is, normal or inferior. If EI is greater than zero, it can be negative or it can be positive. If EI, that is which EI is the coefficient of the income elasticity of demand, if EI is greater than zero, then the good in question is a normal good, such as, for instance, a steak. Steak is a normal good. Of course, when income increases, then you are attractive to purchase or eat, such, for instance, a normal good, such as steak. Now, of course, if EI is negative, then the good in question is an inferior good. Inferior good is a good, when your income increases, your demand for that good decreases. Such as, for instance, riding in a bus, okay? Going to place to or by the boss may be considered as an inferior service. For instance, lentils, the food lentil, which is considered an inferior good. A used product is considered as an inferior good. Of course, why? You buy a used good when your income goes down. Now, of course, the third kind of elasticity concept that we will talk about is the price elasticity of supply. The price elasticity of supply, of course, is represented by ES, okay, which is the percentage change, which is used to measure the responsiveness of the quantity supply to changes in the price. So ES is equal the percentage change in the quantity supply over the percent change in the price. As you can see, as we talked about the price elasticity of demand, we have elastic demand, inelastic demand, unit demand, perfectly elastic demand, perfectly elastic demand. Of course, in supply, of course, we're going to have elastic supply, inelastic supply, unit supply, perfectly elastic supply, and perfectly inelastic supply. And the shape of them, as far as the demand is concerned, the demand is downward sloping. The shape of the supply is upward sloping. So if we're talking about elastic supply, then the shape of the supply curve is more or less flat. It's upward, but however, it's flat, as you can see over here. And if the supply is inelastic, then of course the price elastic supply is going to be less than 1. And the shape of the elastic supply is going to be, a sharp. The supply curve is upward sloping. However, it is sharp, not flat, like this one over here. This one here is inelastic supply. Now, unit elastic supply, of course, the ES is going to be 1. ES, the coefficient of price elastic supply, equal 1. It's called unit elastic supply. And the shape of the elastic supply in this case is going to the 45 degree line, as you can see over here. This is a unit elastic supply. And then also we have a perfectly elastic supply, where ES is equal infinity. Okay, ES equal infinity, similar to what to the discussion we presented when we talked about the demand, curve. Of course, elastic supply, it means perfectly elastic supply means that a tiny change in the price will cause an infinitely large amount change in the quantity supply. So the shape of the supply curve when the supply is perfectly elastic is horizontal, as you can see over here. Okay. Now, perfectly inelastic supply, of course, the ES, or the coefficient of price elastic supply, is 0, is equal to 0, and the shape of the supply curve is going to be vertical, where any change in the price will cause no change in the quantity supplied. Okay, so these are the different kinds of supply. You're talking about elastic supply, inelastic supply, unit elastic supply, perfectly elastic supply, and perfectly inelastic supply. And the difference between these and demand, okay, is that the supply here is upward sloping, and then the demand, in the case of the demand curve is downward sloping. Of course, whether it is elastic, it is flat, the curve. If it's an elastic demand, it's going to be, of course, sharp or steep. The same thing for supply. If it is elastic, then the supply curve is going to be flat, but it's upward sloping.